Students, let's see the next question, 12th number from exercise 5.2. Two APs have the same common difference. The difference between their 100th term is 100. What is difference between their 1000th term? Two APs are given. Two APs have the same common difference, but first term are not same. Let us take two AP. Let us take A plus D, A plus 2D up to infinite, and A common differences are same. A plus D, A plus 2D up to infinite are two APs. Here the difference between 100th term is given. 100th term means we find the difference between two APs. A100 minus A100, difference between 100th term is equals to 100. A plus 99D minus A plus 99 into D. It is capital A, both APs have not first term is same, is equals to 100. That's why A plus 99D minus A minus 99D is equals to 100. Not AA, 99D and 99D cut, and we get differences between the first terms is equals to 100. It is our result number 1. Now we find the difference between their 100th term, 1000th term. A1000 minus A1000 is equals to A plus 999D minus into bracket A plus 999 into D. Open the bracket, 999D minus A minus 999 into D. Both are cut. A minus A is equals to, we know the A minus A which is 100 because from 1. Hence the difference between 1000 term is also 100. Let us see the 14th number. How many multiples of 4 lies between 10 and 250? The 13 number is same as our example. The two-digit number which are divisible by 3. It is same as the question number 13. 14 number. How many multiples of 4 lies between 10 and 250? Multiples of 10 and 250. Multiples of 4. We required multiples of 4. Multiples of 4 lies between 10 and 250. Multiples of 4 means the number divisible by 4. First number is 12, then 16, then 20, up to. First of all, see, 250 is divisible by 4. 250 divisible by 4. The remainder is 2, means 250 does not divisible by 4. The remainder should be 0. Whenever we subtract 2 from 250, we get 248, and 248 is the last number lies between 10 to 250, which is divisible by 4. Here the first term A is equals to 12. The common difference D is equals to 16 minus 12 is equals to 4. We know the last term AN is equals to 248. We need to find how many multiples means the number of terms in this finite AP. Use AN is equals to 248, where AN is equals to A plus N minus 1 into D is equals to 248, where first term A is equals to 12 plus N minus 1 as it is, and instead of D common difference is 4 is equals to 248. By making n minus 1 into 4 as a subject, we get 248 minus 12. That's why n minus 1 is equals to 248 minus 12, 236 upon 4. What is possible? 559. n minus 1 is equals to 59. That's why n is equals to 59 plus 1. That's why n is equals to 60. Therefore 60 multiples lies between 15 multiples of 4 lies between 10 and 250. The question number 13 is related to question number 14 as well as our one example. See the next 15th number. For what values of n are nth term of two APs 63, 65, 67 up to infinite and 3, 10, 17 up to infinite are equal? 63, 65, 67 up to infinite. One AP is given first. The first of all, first term A is 63. The common difference D is 65 minus 63 is equals to 2. We need to find n terms in both the APs. An is equals to A plus n minus 1 into D, where A is equals to 63 plus n minus 1 and D is equals to 2. 63 to multiply with bracket 2n minus 2. 2n plus 61. An is equals to 2n plus 61. Same way we need to find an in second AP. 3, 10, 17 up to infinite. A is equals to 3. Common difference D is 10 minus 3 is equals to 7. Again we need to find an, but it is different from the first AP, so that A dash n is equals to A plus n minus 1 into D, where A is equals to 3 plus n minus 1, instead of D is 7. 3 plus 7n minus 7 is equals to 7n minus 4, which is A dash n. Now for what value of nth term of both APs are equal, we compare both. An is equals to A dash n, where An is equals to 2n plus 61 and A dash n is 7n minus 4. Shift minus 4 right to left and 2n left to right. 61 plus 4 is equals to 7n minus 2n. 7n minus 2n, which is 5n, is equals to 65. That's why n is equals to 65 upon 5. 13 5s are. The value of n is 13. 13th term of both APs are equal. Therefore, 30th term of both APs are equal. Let's see the 16 number. Determine the AP whose third term is 16 and seventh term exceeds the fifth term by 12. Third term is 16, means A3 is equals to 16, and next is seventh term, means A7 is exceeds the fifth term by 12. A5 plus 12. A7 is A plus 6D. A5 is A plus 4D plus 12. AA cut 6D minus 4D is equals to 12. 6D minus 4D, 2D is equals to 12. That's why D is equals to 12 upon 2. 2 6 are 12. The value of D, which is 6. To obtain the value of A, use A3 is equals to 16. A3 is equals to A plus 2D is equals to 16, where A we don't know, 2 instead of D is 6 is equals to 16. That's why A plus 2 6 are 12 is equals to 16. A is equals to 16 minus 12. That's why the value of A, which is 4. The value of A is 4. We require to find arithmetic progression for AP. First term A1 is equals to A is equals to 4. Second term A2 is equals to A plus D, where A is 4 and D is 6, which is 10. Third term A3, already A3 is given in question, which is 16. Fourth term A4 is equals to A3 plus D, where A3 is equals to 16 and D is equals to 6. 16 plus 6 is equals to 22. Therefore, required AP 4, 10, 16, 22 up to infinite. Hence the question number 16 is completed here. Let's see the next one. Let's see the next 18 number. The sum of the 4th and 8th term of an AP is 24 and the sum of 6th and 10th term is 44. Find the first 3 terms of an AP. To find the first 3 terms of an AP, we required A and D both. The given in the question sum of 4th and 8th term. 4th term A4 and 8th term A8. Sum of 4th and 8th term is 24. A4 is equals to A plus 3D. A8 is equals to A plus 7D is equals to 24. Now A plus A is equals to 2A plus 10D is equals to 24. Now here we are taking 2 as a common. That's why A plus 5D is equals to 12, which is our equation number 1. Same way the second thing is given. Second is the sum of 6th and 10th term is 44. 6th term A6 plus 10th term A10 is equals to sum of 6th and 10th term is 44. That's why A6 is equals to A plus 5D plus A10 is equals to A plus 9D is equals to 44. A plus A is equals to 2A plus 9 plus 5 is equals to 14D is equals to 44. That's why A plus 7D is equals to 22, which is our second equation. To find the value of A and D, we first of all solve both the equation. Subtract these equations from each other. Subtract equation 2 from 1. A plus 5D minus A plus 7D is equals to 44. So it is not 44, it is 12. A plus 5D is equals to 12. 12 minus A plus 7D is 22. Open the bracket. A plus 5D minus A minus 7D is equals to minus 10. A cut. 5 minus 7 is equals to minus 2D is equals to minus 10. Minus minus is cut. D is equals to 10 upon 2. 2 5s are 10. Therefore, the value of D is 5. To find the value of A, we use equation 1. From 1, A plus 5D is equals to 12. A 5D is 5 is equals to 12. That's why A is equals to 5 5s are 25 is equals to 12. That's why A is equals to 12 minus 25. Therefore, A is equals to minus 30. The value of A is minus 30. Therefore, 3 terms of the AP. Therefore, first 3 terms of AP. First A is equals to minus 30. Second term A2 is equals to A plus D minus 13. D is equals to 5, which is minus 8. And third term A3 is equals to A2 plus D. A2 is equals to minus 8 plus 5, which is minus 3. Hence the 18th number is completed. Now see the 19 and 20 both are situation type sums. 19 number, Subbarao started work in 1995 at an annual salary of rupees 5,000 and received an increment of rupees 2,000 each year. In which year did his income reaches rupees 7,000? Salary of first year is equals to 5,000 rupees. Salary of second year is equals to increase 200 rupees, 5,200 rupees. Salary of third year is equals to again 200 increment, 5,400 rupees. Therefore, AP 5,000, 5,200, 5,400 up to question is in which year did his income reaches rupees 7,000. We don't know where it is 7,000. It is the nth term. Salary for the first year it is first term. Salary for the second year it is second term. We don't know salary in which year is rupees 7,000. So it is the nth term. The first term A is equals to 5,000. Common difference D is equals to 5,200 minus 5,000 is equals to 200 rupees. In nth year, his salary becomes rupees 7,000. That's why AN is equals to 7,000. A plus n minus 1 into D is equals to 7,000. First term A is 5,000 plus n minus 1 and D is equals to 200 is equals to 7,000. By making n minus 1 into 200 as a subject, 7,000 minus 5,000. N minus 1 into 200 is equals to 2,000. N minus 1 is equals to 2,000 upon 200. 2 zeros are cut and 2 tens are. That's why n is equals to 10 plus 11 and n is equals to 11. In 11th year, his salary, his income reached rupees 7,000. In 11th year, his income reached rupees 7,000. Hence, the 19 number is completed. The 17 number is not skipped. The 17 number, the question number 17, try yourself, which is very easy. See the 20, it is last from our exercise 5.2. Ramkali saved rupees 5 in the first week of a year and then increased her weekly savings by rupees 1.75 rupees. If in the nth week her weekly savings become rupees 20.75, find n. Now what is the given here? Given that Ramkali saved rupees 5 in the first week, which is first term. First term A is equals to 5 rupees. Then next, and then increased her weekly saving by rupees 1.75. Increased, increment is given, which is gives us common difference. Common difference D is equals to 1.75 rupees or simply 1.75. If in nth week her weekly saving becomes rupees to 20.75, nth week means AN is equals to 20.75 and find the value of n. We know here A, D and N. use the formula to find an. An is equals to a plus n minus 1 into d, where an is equals to 20.75 is equals to a is 5 plus n minus 1 and common difference d is 1.75. 20.75 minus 5 is equals to n minus 1 into 1.75. 20.75 minus 5 gives 15.75 is equals to n minus 1 into 1.75. Now make n minus 1 as a subject. We get 15.75 upon 1.75. That's why n minus 1 is equals to 1575 upon 100, multiply 175 and 100 goes to the numerator. Now 100 cut here. Division by 25 is possible. 25 sevens are, and here 1575 divide by 25. 6 are 150 and 3s are 63. 63 into 25 gives us 1575. That's why n minus 1 is equals to 63, n is equals to 63 plus 1 and n is equals to 64. Question says find n, therefore value of n is 64. At nth week, means in 64th week, her weekly saving becomes 20.75 rupees. Here the exercise 5.2 is totally completed. Somewhat sums are try yourself because they are very easy to understood, which is related to our example. Similar numerics are given in a same way. That's why try yourself some sums and practice. If you are not able to get, tick mark it, and whenever we meet, we solve your queries. Exercise 5.2 is completed. Now we discussed our new point, which is sum of first n terms. Hence, here exercise 5.2 is the concept of nth term of an AP. Nth term of an AP means an. Now we will discuss about Sn. Now we see one new theory about sum of first n terms. Sum of first n terms of an AP. Sum of first n terms, as we know, nth term is denoted by nth term, which is an. Sum of first n terms is denoted by Sn. Sum of first n terms of an AP is denoted by Sn. When first term is A and common difference is D, then formula to find sum of n terms. Sn is equals to n upon 2 into bracket 2a plus n minus 1 into d. It is formula to find sum of first n terms. whenever given A5 is a fifth term, but given that S5 is sum of first 5 terms, A1 plus A2 plus A3 plus A4 plus A5. A5 is a single term, but S5 is the sum of first 5 terms. Keep in mind the difference between AN and SN. Okay, it is useful to find infinite number of AP is given. AP is not finite when the finite AP is given, then formula to find sum of n terms, because in finite AP number of terms are finite, then Sn is equals to n upon 2 into bracket A plus L, where L is equals to An is equals to last term. It is a very useful formula, but its formula is used whenever the finite AP is given and we know the last term. Otherwise, we can use the first formula, Sn is equals to n upon 2 into bracket 2a plus n minus 1 into d. Now the second formula is obtained by first one, Sn is equals to n upon 2 into bracket 2a plus n minus 1 into d. How to obtain Sn is equals to n upon 2 into bracket a plus n? Sn is equals to n upon 2, split it, a plus n minus 1 into d. Sn is equals to n upon 2 into bracket first a as it is. We know a plus n minus 1 into d gives formula to find an. That's why Sn is equals to n upon 2 into bracket a plus L. It is not required to keep in mind that remind the two Sn formulas, Sn n by 2 into bracket 2a plus n minus 1 into d, and Sn is equals to n upon 2 into bracket a plus L. Now one most important relation between An and Sn, relation between An and Sn. An is equals to Sn minus Sn minus 1. It is most important relation. Let us see one example for An is equals to Sn minus Sn minus 1. Let us take one AP, suppose 2, 4, 6, 8 up to infinite. Take n as a one number. Suppose a is equals to 5 here or 10 here. A10 is equals to S10 minus 10 minus 1 gives 9. Using formula to find Sn, we are finding S10 and S9. A is equals to 2, D is equals to 4. Sn is equals to n upon 2 into bracket 2a plus n minus 1 into d. Where small n is equals to, first we find S10. S10 is equals to 10 upon 2 into bracket 2, A is equals to 2 plus 10 minus 1 and D is equals to common difference. Here the common difference is 2. 5, 2 2s are 4, 10 minus 1 is 9 2s are 18, 5 into 22, 110, S10. Same way we are finding S9 because n minus 1, 10 minus 1 gives 9, not S8, compulsory S9. 9 upon 2 into bracket 2 into 2 plus 9 minus 1, n minus 1, 9 minus 1 and D is equals to 2. 9 upon 2, 2 2s are 4, 9 minus 1 is 8, 2s are 16. 9 upon 2, 20. 2 tens are, and our answer is 90. Here S9 is equals to 90. Now what happened here? S10 is a 110, S9 is a 90. Then our answer is a 20. Now we are verifying that is it 10th term is 20. To verify it, find the 10th term. 10th term is A plus 9D, where first term A is 2, 9 and D is also 2. 2 plus 18, which is 20. Yes, it is 20. It is the relation between AN and SN, so that keep in mind the relation between AN and SN. It is just an example how they are related to each other using SN, SN minus 1 and AN. Got it? Very well. The relation between AN and the SN. Here simply two formulas for finding SN. There are no more formulas related to the sum of first n terms. There are two, SN and SN. It is useful in infinite AP. It is useful in a finite AP. We know the last term compulsory. In AN is equals to SN minus SN minus 1. It is a simply relation between AN and SN. Whenever we meet in next session, we discuss some notes regarding the SN.